Welcome back. So today what we are going to do is we are going to learn a new topic in Java, obviously, that is called vampire number. So we are going to check whether a given number is a vampire number or not. Now there have been a lot of people, asking me how to check for this vampire number. So what we are going to do out here is we are going to first understand what a vampire number is, and then slowly we are going to break this entire program into several segments and learn each of these segments individually, and then we are going to combine this to understand how to check whether a given number is a vampire number or not. So first thing first, what we are going to do is we are going to check whether a given number is a vampire number or not. So the first criteria is it is such a number which should have even number of digits. So that's the first criteria, that is a number is eligible. I'm not telling it's a vampire number. A number will be eligible to become vampire number provided it has even number of digits. So the first criteria is number of digits should be even. Where in the given number? Of course, should be even. So if n is the given number, it should have even number of digits. So suppose we have a number, say 4, 5, 6, 3. That means this is eligible. 1, 2, 6, 0. Yes, even this is eligible. 1, 3, 8, 5. Even this is eligible. 1, 3, 8, 9, 7. Now this is not eligible because it has odd number of digits. That is, it has 5 digits. So only numbers which has even number of digits, even 21. So it has even number of digits. So even this is eligible to become a vampire number. So that's the first criteria, that is the number should be having even number of digits. Then, okay, the second step is what am I supposed to do? I am supposed to find two factors such that the number of digits in each factor will be half compared to the total number of digits in the given number. So if I have two factors, say I and j, so I will have how many digits? It should have half the number of digits which n has. Similarly, j will also have half the number of digits which n has. So suppose, say for example, the number is 1260. So we will have two factors this way, 21 and 60, which when multiplied, 21 into 60, which when multiplied give 1260. That means the product of these two factors should be equal to the number. That's the first thing. The next part is the most interesting part. How many digits are there in this particular factor? That is 21. How many digits are there? There are 2. So 2 is half of 4 because the total number of digits in the given number is 4. Similarly 60. So 60, again, once again what happens? How many digits are there? There are 2 digits, which is again half of 1260. I can give you one more example. Say for example, we have 2510, say. So now this consists of 6 digits, you can see over there, and therefore we can divide it into two factors, 510, which when multiplied, that is 201 into 510 will be giving me 102510. That's fine. However, notice carefully that the total number of digits, how many digits are there in these factors? In both the factors, there are 3 digits, which is equal to half the total number of digits in the given number. So half of 6 is 3. So that is the next criteria. So you should be able to find two factors such that product is the given number, and next criteria is the total number of digits should be half compared to the total number of digits in the given number. So this was the second criteria, that is finding the factors with those conditions, digits half and the product should be equal to the given number. Now the third part. Now even now we did not get it. Now the factors which you get, which when combined will have the same digits with the same multiplicity, that means with the same repetition with the original number. That is, suppose say for example, I'll tell you what I mean by this entire thing. Suppose this is 1260 because this is the first possible vampire number. So suppose this is the thing, and we get two factors, 21 and 60. Now what we are going to do is, these two factors which we get, we are going to combine it together. Combine it together in the sense that we are going to join these two numbers together. So 21 and 60 when joined gives this. Now you see, every digit that you see will have the same number of repetition. You see, 1 is how many times it is present over here? 1 time. Here also it is present 1 time. 2, you see, all the digits should be present with the same number of repetition. 2 how many times? A single time. So here also 2 single time. Here 6, how many times? Single time. Here also 6, single time. Here 0, single time. Here also 0, single time. So this is what we are going to do. That is, we are going to see that whether all the digits are present in both the numbers or not. Both the numbers in the sense, the first number is, of course, the given number, and the next number is what? The next number is the combination of the two factors, which when combined will have all the digits with the same number of repetition as the original number. I believe you can understand what I am trying to tell over here. So now we'll start with the process of programming. That is, we are going to check whether a given number is a vampire number or not. So what we are going to do is, first, what will be the steps involved? We are going to check how many digits are there. So we'll write the code for that. So we are going to learn first only that much. That is, how many digits are there, and then check whether it has even number of digits or odd number of digits. The next part of the question, we'll do this individually. You need not worry, the entire program I will not show that. That is at the end of it. The next part, what we are going to do is, we are going to find two factors such that what is it? Such that it will have the total number of digits will be half compared to the total number of digits in the given number. So we are going to find two factors, of course, which when multiplied gives the original number. Even this part is there. So this is the second part of the question. We are going to solve this individually. We will not keep any relation with this. And third part, we are going to learn how to combine two numbers together. That's the first thing, because 21 and 60 we need to join it, combine it together. And then what we are going to do is, we are going to check how many times each digit is getting repeated in the original number as well as in this particular number, that is in this particular given number. So we are also going to do that. So this is what we are going to do. We are going to break this into several segments of the program, and then we are going to try the entire program. I believe you will like what we are going to learn for vampire number. Okay, so as mentioned earlier, we had learned there were three steps. The first step, to count the total number of digits and check for whether even or odd number of digits. The next step was finding the two factors with those conditions. And the third step was checking whether all the digits are repeated in the same way in both the numbers or not. So that is what we had learned. Now we are going to individually take each of the steps and we are going to try. Now first step was counting the total number of digits. So first what we are going to learn is how to count the total number of digits in a given number. Suppose n is a number. So suppose n is assuming this is the entered number. Assuming the number entered by the user. Now what we are going to do is, we are going to understand how to count the total number of digits in the number n. We are doing right from the basics. If you know it, fine. You can slightly push forward your video and you can see it. But still, it's better always to see the entire thing. So first we are going to learn or count the total number of digits in the given number. So what do? We start with a for loop. Remember, in the INT declaration, we are going to have a variable I, because I will be using that variable. So I equal to n. We'll go for digit extraction and look at the technique involved. I is greater than 0, and what I write is I equal to I by 10. And here simply, so every time a digit will get truncated. And here what I do is, I'm just going to put a counter. So now you see what is happening, so where C is initially 0. Let's see how this particular program fragment is going to count the total number of digits in the given number n. So suppose the number is 1260. Say the number is 1260. So this is n. So I equal to n. So first the initialization is going to happen. I equal to n. So the value of I will naturally be 1260. And since the value of I is greater than 0, it will enter the loop. And upon entering, there is only one statement inside the loop. That is the also reason why I did not give the opening and closing brace, because if there is one statement in a loop, giving braces is optional. So I enter the loop, and what do we find? C++. We are finding a variable getting incremented by 1. That means actually I am counting one digit. So C++ means the value of C will become 1 because initially the value of C is declared or initialized as 0. And from here, it will get back to the updation part. So updation, what is written? I equal to I by 10. So what is the new value of I? Obviously 126. Now 126 is again greater than 0. So since it is greater than 0, again it enters the body of the loop and C will get incremented by 1. So C was already 1, so the value of C will become 2. Now I equal to I by 10. So this time what is the value of I? This time the value of I will be 12. And once again you can see the value 12 is obviously greater than 0 and therefore C++. So the new value of C will be 3. And again the updation part gets executed. So I equal to I by 10. So next time the value of I will be 1. And obviously 1 is also greater than 0. So again it enters the loop C++. The value of C will be 4. And then again it goes over there. I equal to I by 10. I equal to I by 10. So what is I? I was 1. 1 divided by 10 is 0. Remember, when you divide an integer variable with an integer variable, you always get an integer. I believe you remember this basics. So that is why all the digits after the point gets truncated. You see 1260, when I divided by 10, it became 126, not 126.0. Similarly, 126 divided by 10, it never became 12.6. It became 12 because when you divide an integer by integer, automatically we get the answer as integer. So what basically happens is all the digits after the points get removed or truncated. That is how Java behaves. So ultimately, the value of I is 0. It no longer gets inside the loop. So it comes out of the loop. And after coming out of the loop, it will come to the first statement, after coming out of the loop. And by then, if you notice carefully, C contains 4, which is actually the total number of digits given in that particular number, that is 1260. So this is the technique or trick for counting the total number of digits in a number. The next step is, what we are going to do? We are going to check whether a particular number, that is, in our case, the number is n, whether it has even number of digits or not. So if it has odd number of digits, so we can put an if check. If C is odd, so C is odd means if C modulus 2 is not equal to 0, that means when you divide a number by 2 and if the remainder do not happen to be 0, what does it mean? That means there is no possibility of the number to be a vampire number. So what we are going to do is we are going to raise a flag over here, f equal to 1. Just to indicate where f is initially 0. Please remember this. In the INT declaration, we'll put f equal to 0 to indicate that this particular number cannot be. And here in the else part, we should carry on checking for the second process. That is the second step. That is why I am not writing over here directly, not a vampire number. I could have written over here directly, not a vampire number. But again, you will be having not a vampire number again out here in the next step also. Because there are so many criteria. That is why I am simply raising a flag, f equal to 1. At last I am going to put, if f is 1, at last we will tell that this number is not a vampire number. If f continues remaining as 0, that means all the conditions were fulfilled. That is why f remained as 0 and therefore we can declare it to be vampire number. Now, that is later part. What is important is we learned how to count the total number of digits and we also learned how to check whether it has odd number of digits or even number of digits. Odd number of digits, we are raising a flag. Even number of digits, we are going to check for the next step. Okay, now what we are going to do is we are going to learn the second step. And what was the second step? The second step was we were supposed to find the two factors such that the product is equal to the number, obviously. And the next part was the number of digits in each of these factors should be equal to half of what the total number of digits is there in the given number. Now, the question arises, how do we find factors? Now, what are factors? Factors are those numbers which can divide that particular number completely. So, those who are doing it for the first time, this is for you. Suppose we have a number 6. What are its factors? The factors are 1, 2, 3 and 6 because these are the numbers which can completely divide 6. That means when you divide this number with 6, the remainder happens to be 0. So, suppose we have the number 8. What are the factors? 1, 2, 4 and 8. Suppose the number is 10. What are the factors? 1, 2, 5 and 10. So, if you observe carefully, the factors lie anywhere between 1 till that number. You cannot have a factor which is less than that is less than 1 or more than the given number. That is, if your number is n, you will always have factors lying between 1 to n, both 1 and n inclusive. So, if we need to find the factors of a given number, the most simplest technique will be, I said, it will be the most simplest technique. Of course, n is the entered number or the number entered by the user. This I am assuming. So what we are going to do is, in the int we'll have obviously n, we'll also have I, and we'll start a for loop starting from 1 till that number. So we run a loop from 1 till that number. Now this is not enough. What we are going to do is, we are going to check whether the number n, that means if the number is 6, so I'm running a loop from 1 to 6. Now what I'm going to do is, each of this number which I get, that is 1, 2, 3, 4, 5, 6, each of this number, I'm going to check whether it really is able to divide this number, that is the number which is entered by the user or not. So how do we do that? We simply check if n modulus I equal to 0, that means if n is divisible by I, because the remainder happens to be 0, we can give a message print I. So system.out.print println I. So it's going to display that particular factor. So this is the technique for displaying all the factors in a given number. So I believe you can understand how to find the factors of a number. Here it's slightly different. Here we are going to do something very tricky out here. Now you see, I believe you got this. Now what we are going to do is, now notice this very carefully. Suppose the number is 1260. Now if I take this 1260, or let me take one more vampire number, suppose 1395, that will be preferable, 1395. So now you imagine 1395. You are going to run a loop starting from 1 to 1395 and checking which are the numbers which are divisible by 1395. That is, whether 1395 is divisible by 1 or not. Then 1395 is divisible by 2 or not. Then 1395 is divisible by 3 or not. This way you will continue how long? Till 1395. So don't you think it will take enormous amount of time, just to check, which are the factors of this particular number. It will take enormous amount of time. And moreover, again we have one more issue over here. The factors which we are supposed to find should have digits which is equal to half the total number of digits over here. So if the number is 1395, the factor should be a 2-digit number, because half of total number of digits, that is, we have 4 digits over here. So half of that is 2. So the factors should be having 2 digits. So there is no point in starting checking from 1. Don't you think so? Similarly, you shouldn't be checking for factors more than 99, because after 99 you will start getting 3-digit numbers. So, and for the vampire number, you cannot have a vampire number having 4 digits with a factor 3-digit. So it should be having exactly equal to half the total number of digits in that given number. So that means, if the number is 1395, I should have the factors from 10 to, I can write it 10 to the power 1 to 10 to the, this is for clarity, I'll tell you why I'm writing that way. 10 to the power 2 minus 1. Now what do I mean by that? That means the factors lie between 10 to the power 2 is 100, 100 minus 1 is 99. So that means it's a 2-digit number. So the factors can be a 2-digit number from 10 to 99. So this is what I can do. Similarly, if the number is 102510, so how many numbers are there? There are 6 digits over there. Now we can tell that the factor will be from 10 to the power 2 to 10 to the power 3 minus 1. That means 10 to the power 2 is how much? 100. 2 10 to the power 3 is how much? 1000. 1000 minus 9, that is 999. It will give you all possible 3-digit numbers. So why 3-digit number? Because half of 6, there are 6 digits over here, half of 6 is 3. That is why we are going to apply this technique. Now the question arises, why on earth did I write 10 to the power 2 and what is this 10 to the power 3? Now what basically I did is, I'll take a 4-digit number. Suppose this is the 4-digit number. 5, 6, 7, 8, 9. How many digits? 4, 5, 6, 7. Okay. Suppose this is a 4-digit number. I've just randomly written over there a 4-digit number. Now the factors should be consisting of 4 digits, because half of 8 is 4. So this loop runs from 10 to the power 3 to 10 to the power 4 minus 1. That is from 1000 to 9999. So that means all 4-digit numbers. I am, generating all possible 4-digit numbers. I am yet to, find out the factor. I am only generating the required number, that is 4-digit number. If it should be of 4-digit, if it should be of 3-digit, I am generating all possible 3-digit numbers. So how am I doing? First, remember we had counted the total number of digits in the variable c. So I can tell that you should run a loop for finding the factors from 10 to the power of c by 2 minus 1 to 10 to the power of c by 2 minus 1. I believe you can understand what is happening. Say for example, I'll tell you the meaning, do not worry. Suppose if it consists of 4 digits, like if c is 4. Now if c is 4, what is happening? 10 to the power 4 by 2, 4 by 2 is 2, 2 minus 1 is 1. So 10 to the power 1, 2, 10 to the power of 4 by 2, that is 10 to the power 4 by 2 is how much? Is 2. So 10 to the power 2 is 100, 100 minus 1 is 99. Isn't it exactly this? Similarly, here what is the value of c? C will be 6. So here 10 to the power c by 2 minus 1 will be how much? That is 6 by 2 is 3, 3 minus 1 is 2. So 10 to the power 2. And this will be 10 to the power c by 2, that is 6 by 2 is 3 minus 1, that is 999. Here similarly, here the value of c is 8. So half of 8, so c by 2 will be 4 and 4 minus 1 is 3. So 10 to the power 3, 2, 10 to the power c by 2, that is 8 by 2 is 4 minus 1. So ultimately we get 999. So this is the technique we are going to do. We are going to apply for generating only those numbers where there is a possibility of becoming the factor which we require. That is, the total number of digits should be half as compared to the given number. Now what we are going to do is, we are going to find out those two factors which I have been talking about. And I believe you understood that 10 to the power, stuff which I have been talking about. So here, assuming that n is the given number, that is the number entered by the user. So given number, and c is the total number of digits, which we already learned how to count. Total number of digits in n. So now we are going to find the factors. Of course, we are going to find the factors if it has even number of digits. So now what do? We run a for loop for I is equal to, remember 10 to the power, what did I mention? 10 to the power of c by 2 and then minus 1. This is what I said. So 10 to the power c by 2 minus 1. So in Java, how do we write this? We cannot write it with a superscript, in Java. You cannot type it that way. So what do? We'll write, instead of this way, we are going to substitute it this way. Mat.pow, because this function is supposed to raise a number to the power of another number. So mat.pow 10 to the power c by 2 minus 1. So it will start from here. And remember that mat.pow always has the habit of returning the result of double type. That means a number with decimal point. And since I is an integer type variable, I remember is an integer type variable, so naturally we need to typecast it. So hence this blank space I kept. So we need to typecast this. So this means 10 to the power c by 2 minus 1. So remember, you have to interpret it this way. And where will it end? I will be less than. Remember less than, not less than, equal to. Again the same stuff, that is int mat.pow 10 to the power of c by 2. Right? So it will go till I will be less than 10 to the power of c by 2. That means 1 less than 10 to the power of c by 2. Because I have written less than. And I plus plus. Of course, you can write less than equal to, and you can write this minus 1. Also, even that will be applicable. So you can write less than equal to, and this entire thing minus 1 can also be written. But this will be perhaps smaller in size. And nothing, with the efficiency. Efficiency is still the same thing. So this is what we start with the loop, because the possibility of the factors will be, if it is a 4-digit number, the factors possibility should be a 2-digit number. So it cannot be below that or it cannot be above that. Otherwise, your basic criteria for vampire numbers, will get removed over there. So now, okay, I believe you understood how to put this loop for the given range. Now what we are going to do is we are going to check whether the range of numbers which you are getting is a factor of n or not. So how do I do that? If n modulus I equal to 0. So if n modulus I equal to 0, what I'm going to do is I'm going to find the other factor. So how do I find j is equal to n slash I? Simple as that. So I'll give you an example. Suppose if n is 1260, the first factor which we get is, of course, a two-digit number is 21. Now, what will be j? J will be n, that is 1260 divided by 21, that is 60. So we got the other factor. Now we'll check whether j also follows the same criteria or not, that is whether it lies between this range or not. So if it do not lie within this range, so how do I write? If not, j is greater than equal to mat dot pow 10 to the power of c by 2 minus 1, and j is less than mat dot pow 10 to the power of c by 2. So if it do not lie over here, so what we can do? We can write f equal to 1. Right? So now, if f is 1, there is no possibility of this, j being, within the same range. However, if it lies within this range, so if we get a factor I and if j is the next factor which follows the criteria, that is how do I understand? Because the f will continue remaining as 0. So here we'll put a check. If f is 0, if f is 0, what does it mean? That means we got a factor. That means if the value of f is 0, that means we got two factors which follows the criteria which I have been talking about. And if it is not, f will obviously become 1. And if f remains as 0 out here, that means we got two factors, that is I and j both satisfying the condition. So now comes the next step. And what is the next step? In the next step, what we are going to do is, we are going to learn how to check whether all the digits in the given number as well as in the combined number are there or not. So that is what we are going to do next. So say for example, now what we are going to do is we are going to learn. I said that before, that finding the occurrence of the numbers, whether the occurrence of every digit in the number and the combined number are same or not. So suppose we take the first vampire number, that is 1260, and we know the two fangs, that is 21 and 60, and similarly we have say 102510, and the two fangs are 201 and 510. We can take one more number, that is 1395, and the two fangs are 15 and 93. Now what we are going to do is, this is my given number, this is my n, no doubt regarding it. Now these two fangs, remember this is say I and this is j, which we already learned how to find. So I and j, this is I and j. Now what we are going to do is, we are going to combine these two factors into a single number and store it into a variable, say x. So how do I do that? I can write it this way, 21 to the power of 21 into 10 to the power of 2 plus 60. Can I tell that? That means, what am I doing? 21 into 10 to the power of 2 is how much? 2100. Plus 60. This is going to give me 2160. That is, it's going to combine these two factors forming a single number. Why am I doing this? Because it will be easy for me to find the occurrence of every digit over there. So this is what I am going to do. Now, how do I do that? So can I tell x is equal to I into 10 to the power of c by 2. Remember, c is the total number of digits, which we already learned how to find. So 10 to the power of c by 2 plus g. Can I tell that? Simple as that. You can take any number. Suppose this is a 6-digit number. So I is 201. 201 into 10 to the power of 6 divided by 2 is 3 plus 510. So what do we get? We get 201,000 plus 510. So what do we get? 201,510. So we got the combined, two factors combined together. We were joining it, concatenating it. So this is the technique for combining these two numbers. And after combining, what we are going to do? We are going to follow a very simple step. Now notice this carefully. Suppose the number is 102510. This is n, and after combination, which we got over here, is 201510. Now look at the technique which we are going to apply for checking whether the occurrence of every digit in both the given number as well as the combined number is same or not. So what is the technique we are going to apply? We are going to extract a digit. Okay, always extraction of digits happens from the end. Of course, we'll learn that. And we'll check how many times it is present in this number. So how many times it is present? It is present 2 times. Similarly, we'll take the last digit from here and check how many times it is present in this number. So how many times? Once again, 2 times. So since it is matching, we don't have an issue over here. Again, we go for the next number. So here 1, how many times? It is present twice. And here how many times? Again twice. So we don't have an issue. So every digit we extract, it should be equal to the number of times it is present in this given number, as well as it should be equal to the total number of times it is present in the combined number. So if it is not equal, once again what we are going to do? We are going to raise a flag. So this is what we are going to do. So how do we do this particular code? So what we are going to do is very simple technique. So we'll start with the formula for k equal to n, where n is the given number, and k greater than 0, k equal to k by 10. And now what we are going to do is we are going to run another loop for p equal to n. The p will be equal to n, because I want to check it in the same number itself. P greater than 0, say C1 is, I'm going to find the frequency of that particular digit in the given number, and C2 will be the frequency of the digit in the combined number, that is x. So first we are checking in the same number how many times it is repeated. So p equal to p by 10. Now you see, very simple, if k mod 10 is going to extract a digit, obviously. Of course, you can store the digit into a variable and then you can check it. But this will be more compact or concise. So k modulus 10 equal to p modulus 10. That means an extracted digit from the end is equal to any of the digits in the given number or not. So if it is matching, then what do? We are going to count how many times it is present. So C1 plus plus. So that is what I am going to do. So I am counting how many times it is present. Simple as that. And now what we are going to do? The same digit, that is k modulus 10. How many times it is present in the number x? That is what we are going to find. So how do we do that? Once again, we can run a loop. We can reuse the variable p, because this loop has ended already. So p equal to x, and we do the same thing, p greater than 0, p equal to p by 10. And here we are going to put a check. If k mod 10, that is the same extracted digit from the given number, is matching with any of this number in the combined number, that is x, then we'll write C2 plus plus. So now if C1 and C2 are same, we don't have an issue. However, if they are not same, that means all the digits are not proportionately present. It may be arranged in any order, but it is not in a proportional order. One may be having a single occurrence of the digit, the other may not be having a single occurrence of the digit. So this is what we should do. So if C1 is not equal to C2, so once again we raise a flag f equal to 1. And of course, if you need, you can simply break exit from the loop, because there is no point in continuing further. Otherwise, f will remain as 0 only. So this process continues even after, after extracting all the digits, and we find, f is continuously still remaining as 0. That means all the digits are having the same number of multiplicity. They are repeating same number of times, or all the digits are present exactly the same number of times in the combined number. So I believe you understood. So ultimately, after involving all the 3 steps, that is checking whether it has an even number of digits or not, and then we checked whether it has the 2 factors whose total number of digits is half compared to the total number of digits in the given number, and their product is equal to the number. So that part, and then we checked, the multiplicity or the occurrences of the digits in both the given number as well as the factors are same. The value of f will continue remaining as 0. So if f is 0, ultimately this is what we are going to do, because at any point of time, if the criteria did not match, I made f1. So now if f continues remaining as 0, that means all the conditions were fulfilled. So we can write it's a vampire number, otherwise not a vampire number. So now what I'm going to do is I'm going to show you on my screen how to check, whether a number, the complete program basically. Whatever we had learned individually, we are going to combine that and we are going to see whether, we are able to check whether a given number is a vampire number or not. Okay, now what we are going to do is we are going to check this in our program. You can see I've opened the BlueJ window where the program is written completely, and of course you can download it from my blog, Dave's practicalprogramming.blogspot.com. that you can see even the address is written at the end of this particular video, so you can always download it from there. But here what did we do? Now first we have the scanner object. Remember, we are taking the input with the help of the scanner, and we have declared the variables over here. Next, what do we have? Here I print a message, enter a number, and we take a number out here. So I'm just going to highlight this particular line. This is the line where I'm taking the number from the user, and the number is getting stored inside the variable n. Now what am I doing out here? This particular loop, I think you will be able to recognize this. This is counting the total number of digits. Now if the number of digits is odd, then what we are going to do, we are going to print not a vampire number, and the program ends over there. Otherwise what we are going to do, otherwise we'll start a for loop. I believe you remember we are supposed to find the factors, and the number of digits in the factor should be exactly half the total number of digits in that given number. So hence the loop for I equal to, I have already explained this. You can observe this. Next, I'm checking whether I is a factor of n or not. If that's the factor, I'm finding out the other factor, which is j. So naturally I into j will be equal to n, because this is how I'm finding the other factor j. And now what am I doing? I'm checking whether j is also having the same number of digits as I is having. If it is not having, so if not, then f will be 1, that is I'm raising a flag. Otherwise f continues remaining as 0. So now what am I doing? In the variable x, I am actually combining both the factors, joining together and concatenating the two factors. So I is one factor and j is one factor. It is going to get combined, it's going to get joined and stored inside the variable x. Now there is also one more part. We are going to check whether both the factors, that is I and j, both have the trailing zeros or not. Now I have already mentioned earlier, if both the factors have trailing zeros, it cannot be a vampire number. So therefore I raise a flag and again break. That means exit from the loop. There is no point in continuing further. However, you can also bypass this break also, and in case we get a factor and it do not end with trailing zeros, then what happens? We start to count the presence of the number of times the digit in that given number as well as in the combined number. That is, the combination is formed by the combination of the two factors which are stored in x. So this is what we are doing. I had already explained this part over here. And at last what happens? At last there, if f is 1, we can tell it's not a vampire number. Otherwise we can tell it's a vampire number. So this is the entire method of checking. And this if, basically this if, I'm going to highlight this particular if is basically checking that in case after coming out of the loop, if the value of f is 0, that means we got a pair of factors which follows the criteria for being a vampire number. So there is no point in continuing further. So we exit from the loop, and after exiting from the loop, it is definitely going to check whether it's a vampire number or not, depending upon the value of the flag. That's it. That's the technique. Pretty simple. You can always download it from my blog. The address is given at the end of it, even at the below in the video. Below of the video also you'll find the address given of my blog. And thank you so much. I believe you enjoyed the video. Bye.